Good day, everyone. It's a new day, it's a new chance for us to learn mathematics. I am Grace May Sabandal, and today we have a new topic to learn. This presentation is entitled The Basic Concepts of Mathematics and Elementary Logic, with the theme, There are no concepts and logic without mathematics. This lecture will allow us to understand the fundamental, basic concepts of mathematics to be able to survive the world independently. Before anything else, these are the objectives of today's learning. First, to comprehend and apply mathematical language, symbols, and notations. Second, to choose and apply appropriate concepts and methods from various disciplines. And third, to gain confidence in using mathematics to analyze and solve problems in both school and real-world situations.
Hey, what are you doing?
Oh, hey Minji, I'm learning math again.
Oh, really? What topic are you in now?
Oh, it's the basic concepts of mathematics and elementary logic.
Oh, I see. That's a good one.
I'm actually interested with it. Look, this talks about the sets, relation, and binary function. First of all, it is said here that a set is a mathematical model for a collection of different things. It has elements or members that can be any mathematical object, numbers, symbol, points in space, lines, other geometrical shapes, variables, or even other sets. In mathematics and logic, a set is any collection of objects, whether mathematical or not. A set is typically represented as a list of all its members surrounded by braces. The intuitive concept of a set is likely even older than the concept of number. Some of the examples are the books and the shelves in a library, the bank accounts in the bank, the set of numbers which are 5, 10, 15, 20, and so on, and the even numbers 2, 4, 6, 8, 10, and so on.
That's right. And actually, you can find sets in real life too. For example, the content inside the school bags, the universe, the playlist, the Spotify, and more.
Hey guys, are we late for the meeting?
No, you're okay. It's still early and we're also waiting for Trisha.
Fortunately, as I was too preoccupied with reviewing this topic to notice that I was late. A relation is a rule that associates every element in one set, known as the domain, with a single element or multiple elements in another set, known as the range. It generates an ordered pair set. This is an example of that. The regular Philippine holidays are listed, and to the right of them are the month and dates for those holidays. The New Year's Day is celebrated on January 1st. The Labor's Day is on May 1st. The Independence Day is on June 12th. The Bonifacio Day is on November 30, and the Rizal Day is in December 30. Another example is the set of 1, 4, 2, 5, 3, 6 is a relation. The domain of the relation is the set 1, 2, and 3, and the range is 4, 5, and 6.
Should we hold off on continuing our group study until the others arrive?
Hello everyone, thank you for your patience. I hope we did not keep you waiting too long. Should we begin our group study right away?
Sure, Danica and Trisha will be here today to help us tackle another topic. Are you all set?
I'm prepared. Let's discuss the function this time. A rule known as the function pairs every element in one set, referred to as the domain, with precisely one element in another set, referred to as the range. This means that there is exactly 1 second coordinate for each first coordinate, or that for each first element of x, there is a unique second element y. Take note that 1-to-1 and many-to-one correspondence are both referred to as functions, whereas one-to-many correspondence is not. The following can be used to illustrate the function. The first is the table. As you can see from the image, the following are ordered pairs, as shown on the screen. The following one is through mapping, and the final one is through graphing. A set of points in the plane is the graph of function, if and only if no vertical line intersects the graph in more than one point, according to the vertical line test. As a result, there is a function.
Danica, thank you for sharing this information. And now, I am excited to share my topic with you, which is the non-binary operation. A non-binary operation on a set is a calculation that uses two elements from the set to create another element from the set. A new mass or binary operation using the symbol is defined to be a b is equals to 3a plus b, where a and b are real numbers. For example, what is 4 times 3? The 4 times 3 is equals to 3 times 4 plus 3 equals 12 plus 3 equals 15. Is A times B communicative? Let's verify. If A times B is equals to B times A, 3A plus B equals 3B plus A. Not true for all real numbers. If A is equals to 4 and B is equals to 2, then 3 times 4 plus 12 is equal to 3 times 2 plus 4 is not true. Therefore, the operation times is not commutative for all real numbers. Is A times B times C associative? Let us verify. If A times B times C equals A times B times C, A times 3B plus C is equals to 3A plus B times C. 3A plus 3B plus C is equals to 3 times 3A plus B plus C. If A is equals to 2, B equals 3, C equals 4, then 3 times 2 plus 3 times 3 plus 4 is not equal to 3 times 3 times 2 plus 3 plus 4. 6 plus 13 is not equal to 3 times 9 plus 4. 19 is not equal to 31. The operation times is not associative for real numbers. A binary operation on a finite set, a set with a limited number of elements, is sometimes shown in the table, along with instructions on how to perform the operation. Binary operation times is defined on the set 1, 2, 3, and 4. The table below shows the 16 possible answers using this operation. For example, what is 2 times 2? The answer of it is 1. Is 4 times 3 communicative? The answer is 4 times 3 is equals to 3 and 3 times 4 is equals to 3. What is the identity element for the operation times? The answer is 4. Find the single element that will always return the original value. The identity element is 4. You will have found the identity element when all the values in each row and its column are same as the row and the column headings. Is time associative for these values? 4 times 3 times 2 equals 4 times 3 times 2. 4 times 4 equals 3 times 2. So 4 times 4 is equals to 4. The answer of it is associative for values 4, 3, and 2.
Elementary logic. According to David Kuker, logic is simply the analysis of reasoning methods. Logic is interested in the form of the argument rather than the content when studying these methods. At its core, mathematical logic is the study of reasoning as it applies to mathematics. Mathematical reasoning is deductive, which means that it's a bold drawing or correct conclusion from a given hypothesis. Thus, the fundamental concept is that the statement is the logical consequence of some other statement. The use of therefore in ordinary mathematical English indicates that the following statement is a result of what came before. Here are some examples. First, every man is mortal. Luke is a man. As a result, Luke is mortal. Second, all dogs like fish. Cyber is a dog. As a result, Cyber like fish. Let us now discuss proposition and connectives. A proposition or statement is a sentence that is either true or false. In the absence of further information, the truth tables defines the logical connectives, but they also have English language counterparts. Shown in the screen is a table. You can see there indicated the logic, math, and the English. First, a denial is a statement that is inverse of a statement. This is an example. A tautology is a statement that is always true, and the example of your screen is an example of one. Number 3, a contradiction is a statement that is always incorrect. An example is shown on the screen. The contraposition of the statement if the P and the Q is if Q and the P, an implication and its contraposition cannot be substituted for one another because they are logically equivalent. A predicate or open sentence is a sentence with one or more variables that becomes a proposition when the variables are replaced. For example, the integers are even and y equals 5. Triangle ABC is isosceles. A predicate, on the other hand, is not a proposition. It has no truth value. However, quantifiers can be used to make proposition about predicates. The universal or general quantifier, for example, is used to state that a given predicate is true for all possible values of its variables. This is a proposition because it can also be the true or false. Similarly, the existential quantifier is used to indicate that there is some value of variables that leads to the statement. For example, let x be a real number x2 negative 1 equals 0 is not a proposition. It is a predicate. There exists an x that x squared negative 1 equals 0 is a proposition. For all x and x squared negative 1 equals 0 is also a proposition. And shown on the screen is the final example.
I've learned a lot today. Thank you so much, everyone.
That shall conclude our group study for today. Thank you everyone for making this meeting happen. We'll see each other again. Bye!